Namaste. Today I am going to take a video class on haloalkanes and haloarenes. So we know about hydrocarbons, right? So hydrocarbons are the organic compounds containing carbon and hydrogens, right? So any compound which is having carbon and hydrogen, or in other words, hydrogen and carbon containing compounds are known as hydrocarbons, right? So these are the simple examples: CH4, CH3, CH3, ethane, CH2 double bond CH2, ethene, CH triple bond CH, ethyne, cyclic compounds like cyclohexane, cyclopentene, cyclohexane. Let us take an example of cyclohexane. So other examples like benzene is also an hydrocarbon. It is a compound containing hydrogen and carbons. Carbon and hydrogen containing compounds are known as hydrocarbons, right? So these are the different examples of hydrocarbons. Now, if I replace any one or more than one hydrogens of these hydrocarbons with halogen atom, for example, let us take methane. If I replace any one hydrogen that is present in this compound with halogen atom, for example, CH3, Cl. So one hydrogen is replaced with chlorine. So therefore, this is one molecule. So another example is, if I replace any one of the hydrogen out of this with the bromine, I can also replace this hydrogen with with halogen. So here also I can replace this hydrogen with halogen. So similarly, here also I can replace one hydrogen with halogen. So here also I can replace this with halogen. Here also I can replace one hydrogen with the halogen. Right. So these are the different examples. Here also there are 6 hydrogens on each carbon in benzene molecule. If I replace one hydrogen with halogen like Br. So what we did in this process is, we took hydrocarbons, we have replaced only one hydrogen with halogen. Similarly, I can replace more than one hydrogen with halogen atoms. So these are all molecules are known as organic compounds containing halogens. These all molecules are known as organic molecules containing halogens. Simple, right? So haloalkanes and hydrocarbons. First, what we did is, the definition for hydrocarbons: hydrogen and carbon containing compounds are known as hydrocarbons. So we wrote different examples for hydrocarbons, and we replaced only one hydrogen with halogens, right? So similarly, we can also replace more than one hydrogen of the hydrocarbons with halogen. For example, C double bond C, ethene molecule. If I replace all the hydrogens with the F, so this is known as tetrafluoroethene. tetrafluoroethene. This molecule is also an halogen containing organic compound. This molecule is also an halogen containing organic molecule. So these are all halogen containing organic molecules. First, what we have to remember is hydrocarbon, hydrogen and carbon containing compounds. If we replace one or more than one hydrogen with halogen atoms, such compounds are known as organic compounds containing halogens. Right? So this is the simple part. So next thing is classification. So classification of what? Of organic molecules containing halogens. Classification of organic molecules containing halogens. So this is broadly classified into two categories, two types. One is known as compounds containing sp3 hybridized carbon to halogen. sp3 hybridized carbon to halogen bond. This is one class. Second class is compounds containing sp2 hybridized carbon to halogen bond. So here X means either it can be fluorine, chlorine, bromine or iodine. Right. So these are the main important two classes of organic compounds containing halogen atoms. First one is compounds containing sp3 hybridized carbon to halogen bond. Second one is compounds containing sp2 hybridized carbon to halogen bond. So in this compound we have three classes, three different classes. I am going to write a simple example: CH3, CH2, Cl. One example. So here I am going to write one more example: CH double bond, CH2 double bond, CH, CH2, Cl. One more example. So here I am going to write one more example. Right. So here compounds containing sp3 hybridized carbon to halogen. So halogen is attached directly to the sp3 hybridized carbon. So halogen, chlorine, I am taking an example of chlorine. Chlorine is attached to sp3 hybridized carbon. So saturated hydrocarbon, right? Saturated carbon. It is saturated with hydrogen. So this chlorine is attached to, this is an sp3 hybridized carbon. sp3 hybridized carbon. So another example here also. Here. So just observe this one. Halogen is attached to sp3 hybridized carbon. So this molecule is nothing but an alkane. Right. So therefore this class is known as haloalkanes. This class of compounds is known as haloalkanes. So how we can define haloalkanes now? Halogen is attached to the sp3 hybridized carbon of the alkane. Right. So this molecule is an alkane. For example, CH3, this is an ethane. So this ethane molecule is, in this ethane molecule, one of the hydrogen is replaced by chlorine atom, halogen. Therefore, this is an sp3 hybridized carbon to which the halogen is directly attached. So such molecules are known as haloalkanes. Halogen is attached to alkanes. So in alkanes, all carbons are sp3 hybridized. If a halogen is attached to any of the carbon in alkanes, so in other words, what we can say is the halogen is replacing the hydrogen that is present in the alkane molecule, right? So what is the general molecular formula for alkanes? So it is nothing but CnH2n plus 2, right? CnH2n plus 2. For example, ethane. For ethane molecule, C2H, N is 2 here. So 4 plus 2, 6. 3 plus 3, 6. Right? So C2H6, ethane molecule. Right? If I replace one hydrogen with chlorine, what I have write? General molecular formula for that. So Cn is as it is, H2n. I am removing one hydrogen, therefore I have to less one hydrogen out of this total number of hydrogens. Right? So therefore Cn H2n plus 1. So that hydrogen is replaced with what? Halogen. So this is the general molecular formula for haloalkanes. CnH2n plus 1 X. X is any halogen. Fluorine, chlorine, bromine, iodine, whatever it is. So haloalkanes. So how to define this? So haloalkanes are the halogen containing organic compounds in which halogen is directly attached to the sp3 hybridized carbon of the alkane. sp3 hybridized carbon of the alkane. So in other words, if any one or more than one hydrogens of the alkanes are replaced with halogens, such molecules are known as haloalkanes. So now, another class. Just observe this molecule. In this molecule, chlorine is attached to sp3 hybridized carbon. This is saturated carbon, saturated with hydrogens. This is sp3 hybridized carbon. But that sp3 hybridized carbon is directly attached to sp2 hybridized carbon. This carbon and this carbon is sp2 hybridized carbon. Therefore, the halogen is attached directly to the sp3 hybridized carbon. That sp3 hybridized carbon to which halogen is directly attached is attached to the sp2 hybridized carbon immediately, directly. So such molecule is known as allylic halides. Allylic halides. So what is the general formula for allylic halides? CH2 double bond CH, CH2X. So X is any halogen. So I want to explain it once again. So halogen is directly attached to the sp3 hybridized carbon. So that sp3 hybridized carbon to which the halogen is attached is directly attached to the sp2 hybridized carbon. So such molecule sp2 hybridized carbon of the alkane, that we have to mention. Right? So such molecules are known as allylic halides. Allylic halides. Right? So here allylic halide. So CH2, CH, CH2X. Right. So one more molecule I would like to write here. Right. So here also, this is sp2 hybridized carbon. This is sp2 hybridized carbon. So what about this? This is sp3 hybridized carbon that is directly attached to the sp2 hybridized carbon. Right. So here also, this is sp2 hybridized carbon. What about this? This is sp3 hybridized carbon that is directly attached to sp2 hybridized carbon. So now, if this to this carbon, if halogen is attached, then also we call this molecule as allylic halide. This halide is known as allylic halide. Right. Instead of attaching the halogen to this carbon, if I attach halogen to this carbon also, then also this molecule is known as allylic halide. Because halogen is attached to the sp3 hybridized carbon, that sp3 hybridized carbon is directly attached to sp2 hybridized carbon of the alkane. right? So this type of molecules are known as allylic halides. So here this is known as allylic bromide. So this one is known as allylic chloride, like, right? So third class of compound is, okay, so take a benzene ring. All carbons of this benzene molecule are sp2 hybridized, and each carbon is attached with what? One hydrogen. So now to this carbon sp3 hybridized carbon is attached. sp3 hybridized carbon is attached. To this sp3 hybridized carbon, if halogen is attached, if halogen, generally X, if halogen is attached, so what happened here? Halogen is attached directly to the sp3 hybridized carbon, but that sp3 hybridized carbon is directly attached immediately to the sp2 hybridized carbon of the benzene. So this class of compounds are known as benzenic halides, right? Benzenic halides. Benzenic halides. So under which class we are studying this? Compounds containing sp3 hybridized carbon to halogen bonds. So in haloalkanes, halogen is attached to the sp3 hybridized carbon of the alkane, right? So in allylic halides, halogen is attached to sp3 hybridized carbon, but that sp3 hybridized carbon is directly attached to the sp2 hybridized carbon of the alkene. So such molecules are known as allylic halides. So this is one example, this is another example. So benzenic halide, so here also halogen is attached to the sp3 hybridized carbon, but that sp3 hybridized carbon is directly attached to the sp2 hybridized carbon. This is the sp2 hybridized carbon of the benzene. Such molecules are known as benzenic halides, right? So this is one class. So second class is, so I am going to draw this. So in this compounds containing sp2 hybridized carbon to halogen, right? So let us take an example first. CH2 double bond CH, actually it is an ethane molecule. So if I replace one hydrogen with the halogen, right, this is one molecule. Here halogen is attached directly to the sp2 hybridized carbon of the ethene or alkene, right? Halogen is directly attached to sp2 hybridized carbon of the alkene, right? So one more example. Let us take this molecule. Here also in benzene molecule, all carbons are sp2 hybridized. Now halogen is directly attached to the sp2 hybridized carbon. In these two molecules, halogen is attached directly to the sp2 hybridized carbon. But this sp2 hybridized carbon is the part of alkene. This sp2 hybridized carbon is part of the benzene ring, right? So therefore, if halogen is directly attached to the sp2 hybridized carbon of the alkene, such molecules are known as vinylic halides. For example, if I replace this X with a Cl, so that molecule is known as vinyl chloride. For example, that is molecule is CHCl. Right, that is vinylic chloride. Vinyl chloride, we call it as a vinyl chloride. If we polymerize this, that molecule becomes polyvinyl chloride, PVC, right? So like that. So here the halogen atom is directly attached to the sp2 hybridized carbon of the benzene molecule, right? Such molecules are known as aryl halides. Or they are also known as haloarenes, right? haloarenes. Right. So now, what is the heading of our chapter? Haloalkanes and haloarenes. So this is what the haloarene. But this is not a haloarene. We should not call this as an haloarene. CH2X. Why we should not call this as an haloarene? Because halogen is not directly attached to the sp2 hybridized carbon of the benzene ring. So this is known as benzenic halide. If I replace this X with Br, benzenic bromide, we call it as a benzyl bromide. Right. So this molecule is not haloarene. This is the only haloarene. Haloarene definition is halogen should attach to the sp2 hybridized carbon of the benzene ring. So similarly, what is the first name? Haloalkane. So what is the definition? The compounds containing, in this class, compounds containing sp3 hybridized carbon to halogen bond. So first class is halogen is attached directly to the sp3 hybridized carbon of the alkane. So molecule should be alkane, haloalkanes. If you want to call a halogen containing organic compound as haloalkane, what it should be? It should contain alkane. So any one of the hydrogen of the alkane is replaced with what? Halogen. For example, CH3, CH2, Cl. So this is haloalkane. This is known as haloalkane. Haloalkane. Halogen is directly attached to the alkanes. One of the hydrogen of the alkanes is replaced by what? Halogen. So these are also known as alkyl halides. These are also known as, or they are also known as alkyl halides. Similar to that of aryl halides. Aryl halides. Alkyl halides. Methyl chloride. Ethyl chloride. So similar to this thing, methyl chloride. So haloalkanes or alkyl halides or haloarenes. This is the chapter. This is what we are going to discuss in whole of this chapter. So in discussing haloalkanes and haloarenes, if you want to understand haloalkanes and haloarenes, first what we did is we understood the meaning of halogen containing organic compounds. So if you replace any one or more than one hydrogens with halogen atom, they are known as halogen containing organic compounds. These are classified into main two classes: compounds containing sp3 hybridized carbon to halogen bond and compounds containing sp2 hybridized carbon to halogen bonds. So in this haloalkanes is the first class, allylic halides, benzenic halides. Right, in all three classes. So halogen is directly attached to sp3 hybridized carbon. So in this class of compounds containing sp2 hybridized carbon to halogen bond, vinylic halides, halogen is directly attached to sp2 hybridized carbon of the alkene. So haloarenes or aryl halides, in this halogen is directly attached to sp2 hybridized carbon of the benzene. Right. So now classification of haloalkanes and haloarenes. So now we are focusing on classification of haloalkanes. So only let us take haloalkanes, classification of haloalkanes. So haloalkanes are classified on the basis of, based on the number of halogen atoms per molecule. So haloalkanes means what? Halogen should attach to the carbon, sp3 hybridized carbon of the alkane. Right. So let us take one example: CH3, CH2, CH2, Cl. So let us take general example form. X. Halogen is attached to sp3 hybridized carbon. Right. Halogen is attached to what? sp3 hybridized carbon of the alkane. So therefore it is an haloalkane. So this is one molecule. Okay. I am going to write this is one example. CH3, CH2, CH2, X. One more example is CH3, CH2, CH, to X. So this is X. So I am going to write like this, X. Right. One more molecule I will write. CH2X, CH2X, CH2X. So these are the three molecules. So in this molecule only one halogen is there. Halogen atoms per molecule. For one molecule, how many halogen atoms are there? Only one halogen atom per molecule. Therefore, this is monohaloalkane. So monohaloalkane. So this one is two halogen atoms per molecule. Therefore, it is known as dihaloalkane. So here, three halogen atoms per molecule. Therefore, trihaloalkane. Similarly, if there are four halogen atoms per molecule, then it is known as tetrahaloalkane, and so on. So this is one class. Haloalkanes are classified on the basis of number of halogen atoms per molecule. Right. So now second class is classification based on the nature of carbon to which nature of sp3 hybridized carbon to which halogen is attached. So we know that there are primary, secondary and tertiary carbons. So if carbon is attached with only one carbon, directly. So such carbons are known as primary carbons. Right. So similarly, secondary carbon, the carbon is attached with what? Attached with two carbons directly. Such carbons are known as secondary carbons. Tertiary carbons means carbons are attached with so these are the sp3 hybridized carbons. Remember, these are the sp3 hybridized carbon attached with only one carbon directly. sp3 hybridized carbon attached with two carbon directly. sp3 hybridized carbon attached with three carbons directly. Such carbons are known as tertiary carbons. So I am going to write here primary carbon CH3, CH2, CH3, CH3. So here first carbon, this carbon is primary carbon. This is attached with three hydrogens, but the condition is sp3 hybridized carbon attached with only one carbon. This is directly attached with only one carbon. This carbon is attached directly with only one carbon. Therefore, this is the primary carbon. Right. This carbon is attached directly with two carbons. Right. This is one carbon. This is another one. These two carbons are attached to this carbon. Therefore, it is sp2. This one is secondary carbon. This is primary carbon. This one is attached with 1, 2, 3 carbons. This is one carbon with which it is attached. This is the second carbon with which it is attached. This is the third carbon with which it is attached. Therefore, this one is tertiary carbon. Right. Now, haloalkanes are classified on the basis of the nature of sp3 hybridized carbon to which a halogen is attached. Nature of the sp3 hybridized carbon can be primary, secondary and tertiary. If the halogen is attached to this carbon, for example this one Cl, then it is known as primary haloalkane. So primary haloalkane. When it is called primary haloalkane, when halogen is attached to the primary carbon. Primary carbon is the one that sp3 hybridized carbon to which only one carbon is attached directly. Right. So secondary haloalkane. So another example what I can write is CH3, CH2, Cl. This is the carbon to which the halogen is attached is primary carbon. So because it is attached with only one carbon. So secondary haloalkane. So if instead of attaching halogen to this carbon, if I replace the hydrogen attached to the secondary carbon, then this is known as secondary haloalkane. Secondary haloalkane. So this carbon is secondary carbon to which the halogen is attached. So one more example what I can write is this one is a secondary haloalkane. Right. Similarly, tertiary haloalkane. If I, instead of replacing this hydrogen, if I replace this halogen is directly attached to sp3, attached to tertiary carbon, then it is known as tertiary haloalkane. So tertiary haloalkane. So example for this is, so I am going to replace here CH. This is the tertiary because this carbon is tertiary carbon. So to this carbon, why we call this carbon as a tertiary carbon? Because this carbon is attached with 3 carbons directly. This is the sp3 hybridized carbon. That carbon is attached directly with the 3 carbons. So therefore this is sp3 this is the tertiary carbon to which the halogen is attached. Therefore it is a tertiary halogen. So based on the nature of sp3 hybridized carbon to which the halogen is attached, how we have classified that? So primary, secondary, tertiary halogens. Tertiary halogens. So this is the classification of halogens. Halogens are classified based on the nature of the sp3 hybridized carbon to which the halogen is attached. One class. Another class is the number of halogen atoms per molecule. So monohaloalkanes, dihaloalkanes, trihaloalkanes, tetrahaloalkanes and polyhaloalkanes. Like so now classification of haloarenes. So classification of haloarenes. So haloarenes are classified only on the based on the number of halogen atoms per mole. Similar to that of haloalkanes. So if the halogen is directly attached to the sp2 hybridized carbon of the benzene ring, then it is known as haloarene or aryl halide. So only one halogen is there in this molecule. So therefore we call this as a monohaloarene. So similarly, so if there are 2 halogen atoms per molecule, then we call it as a dihaloarene. So one more molecule what I can write is, so C haloarene X are nothing but halogen atoms. Therefore this is known as trihaloarene. So this is the only class in this. Right. So in classification we have classified in classification of haloalkanes we have classified compounds haloalkanes into 2 classes based on the number of halogen atom per molecules, monohaloalkanes, dihaloalkanes haloarenes, trihaloalkanes, and based on the nature of sp3 hybridized carbon to which the halogen is attached, sp3 hybridized carbon can be primary, secondary, tertiary carbon. Therefore, if halogen is attached directly to the primary carbon, then it is known as primary haloalkane. Secondary haloalkanes, if the halogen is attached directly to the secondary carbon of the molecule, if the halogen is directly attached to the tertiary carbon of the molecule, then it is known as tertiary haloalkanes. So after that, classification of haloarenes is based only on the number of halogen atoms per molecule. Then it is known as that is monohaloarene, dihaloarene, and trihalorene. This is all about classification of haloalkanes and haloarenes. So in this class, what we have discussed is hydrocarbons, organic compounds containing halogen atoms, classification of halogen containing organic compounds into different classes, like the compounds containing sp3 hybridized carbon to halogen bond, and the compounds containing sp2 hybridized carbon to halogen bond. In the compounds containing sp3 hybridized carbon to halogen bond, there are three classes. If the halogen is directly attached to sp3 hybridized carbon of the alkane, then it is known as haloalkanes or alkyl halides. If the halogen is attached directly to the sp3 hybridized carbon, that sp3 hybridized carbon to which the halogen is attached should be attached to the sp2 hybridized carbon of the alkenes, then it is known as allylic halides. If the halogen is attached directly to the sp3 hybridized carbon, that sp3 hybridized carbon, if it is attached to the sp2 hybridized carbon of the benzene molecule, then it is known as benzylic halides. So in all three classes, halogen is directly attached to the sp3 hybridized carbon. So in the second class, the compounds containing sp3 hybridized carbon to halogen bond, halogen is attached directly to the sp2 hybridized carbon of the alkene, then it is known as vinylic halide. Example is vinyl chloride. If the halogen is attached directly to the sp2 hybridized carbon of the benzene ring, then it is known as aryl halide or haloarene. So now, classification of haloalkanes. Classification of haloalkanes. If halogen is directly attached to sp3 hybridized carbon of the alkanes, then it is known as haloalkanes. It is classified based on the number of halogen atoms per molecule. If only one halogen atom is there per molecule, then it is known as monohaloalkanes. Two halogen per molecules, then it is known as dihaloalkanes. If there are three halogen atoms per molecule, then it is known as trihaloarenes. Similarly, another classification is based on the nature of sp3 hybridized carbon to which the halogen is attached. If the carbon is primary carbon to which the halogen is attached, then it is known as primary haloalkanes. If the halogen is attached to the secondary carbon, then it is known as secondary haloalkanes. If the halogen is attached to the tertiary carbon, then it is known as tertiary haloalkanes. Right. So classification of haloarene, it is only based on the number of halogen atoms per molecule. If there is only one halogen per molecule, then it is known as monohaloalkanes, monohaloarenes, dihaloarenes, and trihaloarenes. So based on the number of halogen atoms per molecule. So this is all about classification of the haloalkanes and haloarenes. So thank you.